Welcome to the next day of Advent of Code. We're now officially more than halfway through uh, the nights. We have 13 problems left and 12 done. So yeah, let's see how we do tonight. About 10 seconds left. Getting all my windows ready. And here is day 13. Firewall, several layers. The depth and the range. Okay, must not be detected. Okay, so each layer has a thickness. I see. So, okay, so this sort of, there's a layer immediately inside, a second layer immediately after that. Uh-huh, all right. Moves back and forth within its range, starts at the top. Okay, so it oscillates. All right, so I need to figure out what is gonna be the point, hitch a ride on a packet, 1 layer per picosecond. Okay, so this resembles a problem from last year. The scanners, if there's a scanner at the top of the layer as your packet enters it, I see. Okay, so this is not quite the problem from last year. If a scanner moves while you're there, then you're not caught. So it's when we start. Okay. All right. If you are caught in layers, yep. Okay, makes sense. When the scanner was at the top. Okay, so the scanners are all on a timer. The severity of getting caught is equal to its depth multiplied by its range. All right, so if you leave immediately, what's the severity of your whole trip? Oh, okay. So that makes things a little bit easier. All right, so we're gonna parse our input here. Okay. All right, and then maybe def some p here for like depth, and I'll just put f for kind of like the frequency of it. And we just want to read string of replace in depth this colon with nothing here. And like something like do this. Okay, so map p here. All right. Oh, right. And then we know that f itself doesn't need to be changed at all. Okay. Here we go. All right. And then so it's saying, so we need sort of something like step, and then our state is going to be something like our position, which is a depth, and our severity, which will start at 0 maybe, and yeah, then let's see, maybe like the state of each of the scanners. Let's see, if they all start at the same one, then I don't know that we even really need to say that. So really, as we move through, so okay, maybe we'll have here our like our input here, and let's see, as you move through, so we know that. Okay, so maybe the input is just going to be like some n here, which is might do something like this. Okay, and then so like we say like if caught in some situation, then we need to bump. We always are going to return like increment the position here, and if we're caught, then we need to increment the severity by multiply. So I think it was the square of the depth. Depth multiplied by its range. Okay, all right. So, okay, so we'll have this in be the depth, and so calling it range, I'll continue to call it f here. Okay, and then so, okay, so we'll say depth f, like this. Otherwise, the severity doesn't change. And then finally, yeah, like something like ink. Does this make sense here? I think this all does make sense, except maybe the thing that we want to be iterating over is something like this. And yeah, all right, I think I like this. And then these are the only things that we have to return. And then, okay, so we need an implementation of caught, which depends on position, I guess the frequency and the number n here. So caught at a given position for these three inputs. Actually, position and n are the same thing. So I guess I can kind of take one of these out. I can just say, I just call this the severity. Okay. And then this is really just, is it the case that the remainder of f by n is 0? All right. Okay, and then we got to do something like, so I think we can do like an indexed, something like this. Maybe here, what does this end up looking like? Okay. Oh, okay. So this is actually not quite the right thing here. So the problem is that we actually have to look this up. So this needs to be more like into a map here because, okay, yeah, that seems better. All right, we're going to define this just in. Okay, and then so a position and a severity that we've had so far, we know that we're going to increment the position. And okay, so this looks good. And then the inputs coming in are going to be, do we need anything coming in? Yeah, I think we need just, no, we can sort of take this, I think. Okay, and then we can, so let's see, so caught, we need to be able to get the f value out here. So I think we need to say something like, if let f be take in provide position here, then check for it you being caught like this. Otherwise, return severity like that. All right, and then calling this whole thing, I think is something like iterate step, and then we know that we need to get to the end. Actually, we could probably just like take 100 of these because we know the severity isn't gonna like increase at all toward the end here. So if we have a definition of caught, definition of unable to resolve symbol n, okay, call that just the position here, and then depth. Oh, right, okay, depth, which is the same as position. All right, and then iterate step, starting with position 0, and okay, and then it's saying division by 0 problem, but this lookup here, okay, so given 0 steps, okay, so this is saying that this is the wrong way to, yeah, this is the wrong way to do it. It needs to be like this. Okay. All right, vector can't be cast to a number. Okay, iterate step, starting with here. Add to the severity, multiplying position by, let's see if we can see it quickly here. So this is in the add step. Okay. Okay, severity is somehow coming in as a list. Oh, right. Yep. Okay. All right, so this is the severity. Okay. 1596. Not the right answer. All right, here we go. In this situation, you're caught because your packet, when its scanner was at the top, you're not caught in layer 1. All right, so let's look at this here. So initial states are that all the scanners are here. Then you're here. Okay, which I think we agree with. All right. And all right, so let's do something like this here for some input 2. All right. Okay, we got our alternative here. And so this says 16. All right. Okay, so maybe we can say like, if this is the case, PRN like that here. And it's saying that you get caught at levels 0, which is correct, and 4, which is wrong. Okay, so what's the problem? So at level 4, basically, I think it's saying that I think I have an off by 1 error, because where 0 steps have passed, well, now 4 steps have passed. 4 steps have passed, but doesn't 4 start it? So 4 starts up here. Okay, then picosecond 0, 1, then it moves. Picosecond 1, yep, then it moves. Picosecond 2, yep. Picosecond 3, yep, it's here. Okay, I am misinterpreting how the scanner works. Oh, I see, it goes back up. Okay, so in this case, so what are the, okay, so it goes back up and it keeps bouncing around. Okay, so it doesn't cycle through. So, all right, so then in that case, the numbers go, so like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so these basically go up by the number, it's like the number times 2 minus 1. So take this number, multiply it by 2. Oh no, it's minus 2, I'm pretty sure. Okay. Okay. Yep. New number. Because it gets caught at. Okay, so yes, that's good. And then here, here, here. And change this back. Here, 13, 16. Right answer, rank 145. Okay, going back. My guess is, how do you minimize your, fewest number of picoseconds? Okay, let's see. The fewest picoseconds to get through safely. Yeah. Okay. So then, caught given a delay D is just going to be to this number. You're just going to add D here, and then your caught implementation is just going to be All right, and we're back. Let's share the screen. Okay, here we go. Yeah, so not sure what happened there. Just crashed pretty hard. So you get to see how I set up my environment, I suppose. And let's see, do we still have the inputs, or do we have to download those again? Yeah, no, looks like there's nothing there. Okay. Yeah, I don't know. I don't restart my machines a whole lot, so it's possible that maybe it just accumulated too much garbage or something. But yeah, it just became completely unresponsive. I couldn't move the mouse. I couldn't close the lid and get a response there. So I doubt we're going to get doubt we're going to get points here, but haven't actually checked. May as well play to the whistle, as it were. Okay, and I need to get my port number here. All right, here we go. Okay, yeah, came back so quickly. Eclipse seems like it's unsure that this is even a closure. Closure file. Missing the old syntax highlight. Okay. So, all right, let's see how far we can get. Line 111. Right. Yes. Okay. So in this situation, okay, so we need to specify an n getting passed in here. I think that we can just make this n, or actually we'll call it d as part of the delay. And then we just make it part of this. So sort of like for d in range 11, we can take this here, and then well, since it's only 10, we could probably just look at them. Okay, unable to drop symbol in. Okay, like that. All right, and then here. Okay, here. All right, and then this is telling me that the severity doesn't change. What? Oh, okay. Yeah, my change here was not caught before my computer died. All right, and no pointer exception. What? Right. Yeah, because the delay D has to be carried forward. Okay, and apply min key second to this thing here, and it says delay of 9 results in a 0. Oh, okay. So, what's the fewest number of picoseconds that you need to delay to pass through the firewall without being caught? Oh, I see. It's a different problem, but with a surprisingly low answer. Does that make sense? Does it? I mean, according to this, it makes sense. All right, so 9 picosecond delay. Not the right answer. What? I'm kind of surprised that there would be something special about 9. If you look at all these other numbers, I wonder. No, no, I'm not sure. What? Huh? Um, what would cause some behavior like this? I mean, oh, I guess we can just check against this thing here. So let's change our algorithm around a little bit. So I think, okay, so this is without being caught at all. Okay, so instead, I think that we just want to do something like filter comp 0 second here and take the first one of these and range, something much bigger like this. Get, all right, okay, got to get the inputs again. Where are they? Here they are. Okay, and then we call this input 2. And all right, load that in, change this here. Let's try to get this. All right, and then this says a delay of 1 is enough to do it. All right, so is my implementation of cot not correct? I mean, it must not be. I mean, this is saying that if you have a delay of 1, then the severity is 0. Okay, cot, take F and D. All right. Did I read delay incorrect? The implementation of delay, did I not understand it? Can't control the speed of the packet, but you can delay it. Okay, if you're not in the firewall during this time, you don't enter layer 0 until you stop delaying the packet. You won't get caught. Well, okay, so, well, so it's saying that if I set delay to be 1, okay, so what if I just return this value, or print out this value here? Yeah, okay. Yeah, should only be taking like 10 of these. All right, so it says our remainders are 0, 1. Okay, so I'm getting caught in the first. Oh, that's what it is. It's because I'm checking for severity, and yeah. Okay, so yeah, so basically, well, so this should work, I think. Yeah, okay, how about now? Great, noisy. Okay, make another REPL here, close this, turn my print line off. Okay, and then this answer. All right, and this says actually it can't find an answer. Okay, so that's not good either. So this is at least properly tracking that it gets caught in step 1. If I provide 10 here, then it's saying that it gets caught also in step 1. Okay, but we know that it doesn't. All right, so we're delaying 10. It's saying that you get caught in step 1 because this has a cycle of 3, which means that I guess you have 10. Yeah, okay. Okay, so I think that it's actually, yeah, this I just put this in the wrong place. Okay, so I think it's supposed to be like this, and like this, which is 0, this, which does give 10, and then we switch this back here. Uh-oh, not in the first 10,000. Okay, how about 10,000 to 100,000? Tough, yeah. Maybe I need faster fail out of the step function here. Yeah, maybe maybe one way to sort of approach this. Ooh, all right, is I could let's see, I could maybe take just like increment the severity here. Okay, and then maybe what I can do is do this kind of thing. And then what if I just take like 30 of these values? Okay, so it's saying 7, 4, 1, 5, 1. Lots of ones. All right. That's huh. Okay, so let me go back here. All right, so in the first case, here, let's just a little bit further. Okay, lots of ones saying that there's basically only one point in here where we get caught. So my guess is that, why would there be only one? My guess is that maybe like this number for all of these things is maybe it has some kind of property about it. Okay, well let me just try this with slightly. Let me just set this off in a different REPL, and let it crank, because programmer time is a lot slower than computer time. Okay, so all right, so this will just go. Let's see. So then, I think basically we would probably want to have something where the step function was like aware, where we could say like if position is greater than 92, we could just or just return D. Otherwise, we like, let's see. So if we're caught, then we want to return something like, actually, what we could do is yeah, I'll just actually no, we'll do reduced fail, reduced D here, and then in the other case we just return increment position, keep severity the same, doesn't matter, and then keep D the same. And then now what I think we can do is something like in our, okay, still not done. In our search space here, we can say something like, well, so maybe it might be nice to like time this before we like see claim that we got like good speed improvements here. So let me time this thing, which I think only took like maybe 10 seconds last time we ran it. Okay, I guess it took more time than that. So anyway, then we'll have like a solve for some value D, which is going to be like, okay, so this is also going to take like a state here that doesn't matter. Okay, so let result X be reduce step starting with 0, some severity, and E here, and then working over range 93, something like this, and then I think we can just say if number X, then return X. All right, and then we say something like, in this thing here, this got renamed somehow. Okay, call solve on D. Let X be this, and X emit this, and then return first these things. And then we can time this. Okay. Doesn't know how to create wrong number of args passed to step. Yep. Okay. Any arguments to if? Let's see. So if let. Okay. All right. So yeah. Yeah, I agree. That's too many arguments. Okay, so otherwise do this. All right, and then so I guess we want this to be here, that to be there. Okay. Okay, that seems like it's a whole lot faster. Okay, and this failed because of redefinitions. Okay, so yeah, let's say let's just start with these numbers and try to find something that that works. So so yeah, this does give us a fast fail behavior. Seems like we improved our speed by, let's see, from 40 seconds to 200 milliseconds. So it's a pretty good speed up. So now we're just cranking away. It would be nice for this process to be inspectable a little bit so that I could get an idea for how far away my solution was. Also, might not be such a bad idea to take a look at the leaderboard and just see if other people are struggling. That wouldn't be it wouldn't be totally out of the ordinary, but it seems like no. In general, people didn't seem to be struggling with like getting to these numbers here. Which makes me think I'm doing something wrong. Like, okay, so anyway, good way to test this is to change change this to int2 here, and yeah, basically the number starting with 0 and trying to get the answer out here. And okay, it's not getting it is not getting the right answer. All right. Okay, so it's saying, so this, I think this worked previously. So this is returning nil. Okay, reduce this. Okay, my guess is that I'm not catching one of these cases here. So let's see. So if position is greater than 92. Okay, so there's our thing. Okay, so that should come out that way. Then this to here. All right. Okay, this looks fine. Then the other side of the flat. All right, so somehow step is returning nil at some point here. All right. All right. Oh, here we go. Set this to 10, range 9 here, and reductions. Okay. 0. Okay, but then what's up with this? Okay, well then why was solve? Okay. Well, shouldn't this have returned at this point here, or was it because this actually needs to be range 94? Ah, okay. So that seems to be part of my problem. Need the number to be just a little bit bigger. Okay, and okay, so we have an answer here. Looks like it was a pretty big number. So let's plug it in. All right, right answer, rank 262. Very good. Okay. Let's see. So ordinarily, I would sort of go over this problem and the things that went right and wrong tonight. But I'm actually going to join my buddy's YouTube channel. He's doing these problems in Haskell, or at least I think he's been doing them I think he's been doing all of them in Haskell. So I got to assume that he is taking more time than I am, even with the bugs and mistakes and everything. So I'm going to call it a broadcast here. But if you'd like to hear us talking about the problem and Advent of Code and any other topics that interest us, go look up Alan Malloy's channel. He's just another YouTube Advent of Code streamer. So well, he streams a lot of other stuff too. But it should be a pretty good show. I hope to see you there. And oh, does it still have the? Oh no, doesn't have the music up. Does it have my title? Oh, okay, good. All right, so let's see if we can load up real quick. I don't have the music quite queued up, so just imagine your favorite Christmas song, and ho ho ho. Thanks for watching.